right, guys, welcome to the Advanced Refrigeration Podcast first video training. Today we're going to be going over the E2 controller on how to program and add a circuit. So I'm going to be showing you guys this in terminal mode. So as we start out here, it's going to be a little laggy because it's in terminal mode, but this is the best way to do it without pointing a camera at a controller. So first things first, we're going to log into the controller with whatever password. This one is user pass, which most controllers coming out are going to be unless your customer's changed it. So first things first, we're going to go to the menu. We're going to go to number 6, which is add or delete applications. We're going to go to number 1. We want to add an application. We're going to hit F4 for lookup, and we are going to, you have a couple different options in here. You have a case control circuit. If you're using XM stuff, you're going to choose a case control circuit. We are using a standard circuit, which is the E2 is going to be controlling everything, so number 22. So we're going to go down, we're going to tell it how many you want. If you're going to do a bunch of them, say if I'm going to do like 20 at a time through the whole store, I'll add all 20, and then I can address them as need be. But we're just going to add one today. Hit enter, and it's going to ask you if you wish to edit. You're going to hit yes. Okay, so it's going to populate up the screen. So the first one's going to be your general screen. So your name is going to be whatever it is. So we'll say A09 low temp doors. Okay, then long name you could put in there. I generally put the model number of the case just so I know if I'm looking at it remotely. Case type. You could leave this undefined or you could look it up. If you don't put it as something in here, during ultrasight, if you look at the graphical mode, you won't have any graphics. So I usually just pick one. It doesn't have to be, exact, but otherwise you won't have any graphics on ultrasight. Then down here, next option is going to be the number of case sensors. So this is going to be the number of cases you have or number of sensors. If you have 0 sensors, put 0. If you have 5 sensors, put in what number you have. So we'll go 2. And then product sensors. If you have product temp sensors, this is where you would put them. And then dual temp enable. So if you hit yes, it's going to enable for dual temp. If not, it's going to not. Then we're going to go down to temperature control strategy. Now this is one that a lot of guys go back and forth on. So if you hit lookup, you have monitor and defrost. Monitor and defrost is going to be if you have a EPR. Basically that EPR is going to be controlling temp, and then the actual circuit is only there to control defrost. That's the only time it'll cycle that EPR off. Now if you have temperature defrost, this would be if you had like liquid line solenoids, suction stops, stuff like that if you didn't have an EPR. Temperature and defrost you want to try to avoid because it leads to a lot of cycling. If you do use it as a backup, you need to make sure you have the EPR set way higher than the actual temperature. Then you have multiflex ESR. Lineup ESR. This would be for the old style ESR boards. And then multiflex ESR is going to be your newer multiflex ESR boards. So if you're controlling off of an electronic EPR, you're going to choose that option. So we're going to go with monitor and defrost. Okay, case control method. So you have a couple different options here. If you hit lookup, which is F4, you have average, which is 99% of the time we're going to use minimum, maximum, first, and mix. A mix would be a difference between a few sensors. An average is going to be an average, a minimum is going to be the lowest, maximum is going to be the highest. So I always choose average. I've never used mix. I've used minimum a few times. I've never used mix. Using case display, I've never used this option. And then down here we have your fan status. So if it's a walk-in, you're going to use this. Generally cases you don't. Now it is fan off during defrost, fan off during pump down. This is where you could change this. If you're not controlling the fan with CPC, then I never even mess with these. And then cleaning switch. If you have a cleaning switch mode or a door switch, there's going to be your next options. So this is where you would tell it yes or no, and this is going to populate additional menus for you. So once you get this filled in, and we'll tell it has a clean switch, we'll hit lookup, and we're going to go down to equipped, and it's going to change some options. So if we hit the next tab, we're going to go to our case temp set point. Okay, we'll say -10. And I'll show you if you go back and you change this to temperature and defrost, from monitor and defrost, it'll populate a different tab on there. So if you hit F4 look up, and you go to temperature and defrost, when you go to your set points tab, and make sure I'm in full. That's another thing, guys. Make sure it says full at the top, FULL, right under the outdoor air temp. I wasn't in full mode, so I was missing some set points. So here's our temp dead band. So our temp dead band is going to be used for control. So it's going to be split 1.5 degrees up and down. Now, if we were to go backwards and go change it to multi-flex ESR for the temperature control strategy, and we go down to multi-flex ESR, and we go to our set points tab, now we're going to have something called throttle range. So throttle range is the range in which this valve is going to modulate off of PID around that set point. If you ever don't know what something is in the suction group, come down here and hit this question mark on the controller. So it's going to give you default range, and then it's going to tell you the throttling range is the range of temperature equally above and below the case temperature set point to determine the PID percentage called on for by the controller. So basically that's going to be your control. I generally try to run open cases at like 7. It's going to make the valve more responsive, and I try to leave walk-ins around 10. I don't like to go higher than that because then you get some like overshooting. So then we're going to go to our next tab, which is going to be defrost. Okay, your first option is defrost type. You hit lookup. You have all these options here. You have none. You have off cycle, which is going to be turning off the refrigeration, like medium temp. Reversed air would be some older Hussmann cases where you had reversing air relays where the fans would turn around. I mean, you don't really see that too often anymore. We have electric, which would be electric defrost, hot gas, and then you have reverse cycle. I've never used reverse cycle. So we'll choose hot gas. Okay. Now, here's the thing with hot gas. Now you have to associate it with the suction group. If it's enhanced suction, you have to do it in the suction group. If it's a normal suction, you would do it in this screen. So I have no suction group programmed in this controller yet. It's going to be a different video. So we have nothing to do with that. So your next option is pulse defrost. Not a big fan of pulse defrost because, especially with hot gas, it leads to a lot of issues with the receiver level because you're constantly starting and stopping the defrost on the termination. So I'm not a big fan of it. But if you have issues with cases overheating, I mean, it can help. So pump down delay, I generally don't put more than a minute in there. I mean, unless you're pumping something down. If you have a liquid line set on the rack and you're actually pumping it down for off time, then I will put like a 5-minute time delay in there. Next is your defrost duration. So this is where you put your defrost duration in here. Okay, defrost delay, I never use this. I see guys a lot of times make a mistake and they'll put the duration in the delay and it'll actually delay defrost that. Next is your drip time. So you put whatever drip time the manufacturer calls for. And the next option is your term type. So if you go down to hit lookup, F4, you have time, which would just be the actual defrost time. Thermostat, which would be a digital closure, open or close. You can make it either one. You have line temperature inputs. I'm sorry, term temperature inputs, which would be actual term sensors, and you have case temperature. So case temperature would be the actual case itself. I always choose term temp inputs, even if I'm using the case temperature inputs. The reason being, if you do not choose term temp inputs, it will not allow you to change the termination. It won't allow you for a minimum defrost time. If you put in just off case temperature, you get no minimum defrost time. So now, see, we changed that, and now we have more options. So minimum defrost time, I always go half of what your max defrost is. So if it's 20 minutes, I go 10 minutes. So that way, no matter what, you at least get half the defrost time if your term sensor were to fail. So that way you don't ice up. So now we have a term sensor set point. So if you come down here, you could change your term sensor set point to whatever, say 60. This DNT advanced type, a lot of people don't use it. It's a great alarm, but again, it makes alarms. So this DNT is a termination alarm. It'll alarm if that case does not reach defrost termination. I wish they used it more, because I would much rather get called out for a case that didn't terminate the first, 1 or 2 times than be out there de-icing a case when I could have figured out the issue way before. So number of term sensors, 1. And then down here, this term combination. Most chains go with average if you hit lookup. I always go minimum. So that way the case, whatever case is the lowest term sensor, ends up terminating. If you have icing issues and other stuff, then you're going to have to play around with it. But usually minimum gives you a little bit better defrost. And then defrost start 20%. I've never had to change this, but if you come down here, it'll tell you it says the period after a scheduled defrost, that the time during which a defrost cycle may be initiated. I never ever have to mess with this. You generally at 20%, how it is at the factory, is fine. So if you get out of here, you want to hit F5 to cancel. So now we're going to go to our next tab, which is defrost times. So you have 2 options here. You have a schedule, which a lot of people use, or you have numbered. I use numbered defrost, especially when building my stores, because it's a lot easier to do. So if I tell it, this is how I do it. If I say number of defrosts, I say 5. Okay, it's going to evenly space those out during this time. So it's a lot easier to build a balanced defrost schedule. So say I start at midnight or at 1 a.m. So I start at 1 a.m. So it's going to balance those out between 5 defrosts a day at 1 a.m. So then next I'll go to the next one at 1:30 or 2 a.m. So that way I have a balanced defrost schedule. I'm in defrost, I'm out of defrost. I'm in defrost, I'm out of defrost. So that way that rack is constantly, not just cycling all crazy. It's a lot easier to balance out your defrost load using numbered. So a lot of more people are starting to use numbered. So if we hit the next tab, we go to our inputs. So this is where you have your clean switch. You could assign a board point. Now there's a couple ways to do this. You could put board 1 and then go over and hit board 1. It's not going to let me save these because they're not actual points. So no. So if you ever have this problem and you can't get rid of it, hit the space bar and then hit the space bar on the E2 and it'll cancel out the board points. And this is where you would put your case temperature inputs, your defrost termination inputs. So if you hit lookup, if you don't just punch your numbers in there, you hit lookup, you can choose the board in here. So we have 16 AI board 1, and you come over to here and you hit lookup again. It'll give you all the points that are populated. So if we go, we'll just choose 08 temp for right now. So it's going to assign the temp to that. And if we come down here to the term sensor. I always, if I'm using the actual case temperature sensors, like the discharge air temperature sensor, say for medium temp, I always use the temperature sensor again. So that way I could have the minimum defrost time. So I'll go back and I could choose lookup. I could choose OA temp. So I'll make the defrost term and the discharge air the same. So that way it'll register and it'll show it has two temp sensors the same in the E2, but it's going to allow you to have more options. Okay, this lead circuit, this would be for your like coffin cases. A lot of times do this where you have multiple different sides of a coffin, so A, B, C, D, and then you have a main one controlling the defrost. This is how you would assign it. So if you go down here to hit edit, which is F3, you have alternative IO formats. So you have three options: board and point, which is like board 1.1. Okay, area control property, which we're going to be talking a lot about later on. Area control will be different applications in the E2, so like a sensor control, a suction group. You're controlling it a point from a point. It's not a physical point, it's a virtual point. It's a network variable. And then 3, which is fixed value, is going to be either on or off, true or false, or an actual number. Very rarely to use a fixed value, but most of the time you're going to use area control or board point. So if we choose area control, you could hit lookup now. You could choose this controller, which is RX300. Okay, you scroll to the side to application, you're going to hit lookup. So we could choose this random standard circuit, and you could hit lookup. Give me an error. You don't have to do that with this one. It just needs the application. Okay, then valve manufacturer and MSR ComStat. We'll go over that a little bit later. So if you hit F2 to outputs, so now this is where all your outputs are. So you have refrigeration solenoid, EPR valve, defrost, fan. So that's going to be whatever it's going to be. So you have a couple different options here. You could go hit lookup, and you could choose an 8RO board. And you could go to the side, and you could hit lookup, and you could choose your point. So if we go 0.1, or you could type in board 1.1. So EPR valve, same thing. You could put it in there, but there's a way to associate the EPR valves, which I'll show you in a different video. Which you don't want to manually do the EPR valves. You want to let the controller do the associations, so that way you don't have to do any of the extra work with it. So if we come down here, your alarm out. This is if you have an individual alarm point for a case, meaning like Aldi does, where they have security alarm points for they only have 8 circuits, so each circuit has its own alarm point. This is where you put the board point. This is where your control term temp out is, your case alarm temp out, your valve fail safe. So all your outputs are going to be in here. All your statuses. A lot of these are not actual, won't be physical board points, but they'll be virtual board points. They can network variables out. So if you scroll down like defrost active, I hit it one too many times and it's seizing out a little bit. So if we hit the next tab, okay, so now we're in alarms. So case temperature high alarm. This is where you put your high alarm. This is where you put your low alarm, and then your alarm delays. Okay, then you have a delay after defrost. So that's going to be whatever the customer spec is. Your alarm Hysteria. This is one that gets guys a lot. So if you look over here and hit this, the alarm Hysteria is the number of degrees a case temperature sensor value must return above the case temperature low alarm set point or high alarm set point to be considered, the alarm to be considered return to normal. So if it's set to 2 degrees, so meaning if your alarm's at 20 and you're at 20 or 19, it's still going to be an alarm. It's not going to clear until it gets to 18 degrees or vice versa. It keeps stuff from like hanging out an alarm, like just hovering right above or below. And then down here you have your alarm priorities. So alarm priorities are going to be kind of customer driven. Most alarms are going to be 20. 99 is a notice. So if you come down here, you have a combi alarm, and then you have your alarm delay, and then you have your notices. Notices are going to be, they won't alarm out on the alarm output, but there'll be an alarm tab in the controller for that. So next tab is going to be notices. This is where you, like I just said, all your notices. So if you come down here, they have the notice priority to 50. So that'll, however they have it defined in the controller, is going to populate on the screen. So you have your case temperature high, case temperature low, your notice to low, cleaning notice. You could put it to yes or no, where it'll pop up on the screen and tell you it's in clean mode. Case NTC priority 50. So your notice high alarm priority combo, your notice low alarm priority combo. I generally don't use any of these. I don't use a lot of notices. So if we hit the next tab, this is going to be for your PID for your actual ESR. So we never use the D value. Usually we just use PI loops. So you can change your PI loops in here. So the default ones work pretty well. You can play with it a little bit if you need to. And then down here, this is one I use a lot, is this start defrost. So if you hit lookup, this is really good for coffin cases or stuff where you have multiple different zones on one case. If you look up, we're going to choose an application. We'll choose the standard circuit, and then we'll go to the side. This is the start defrost tab. It's not going to let me do it on this one. Let me scroll over. No. I don't have any of these set up, so it may not work. So you would tie that to the actual start defrost, so to the defrost output. So the start defrost, anytime this start defrost gets a defrost signal from the main, it's going to throw this case in defrost. So this is really useful if you have a coffin case and you're trying to defrost them all at the same time, but you have like 5 different circuits. So if it's A01A, A01B, A01C, A01D, and they're all their own zones, so you would let them go to defrost all at the same time. So from A01 main, the defrost output would close, and then all these would go into defrost, and they would time out. It's a lot easier to do the alarms and everything else this way, because then everything starts defrost at the same time, rather than putting the defrost all at the same time. So if we go to our next tab, I have to see, it won't let you go forward because this data stream is not complete because there's no output. So if you mess up and you accidentally put something there, just hit the space bar, go over to the side, hit the space bar, and then now you can move forward. Emergency override is always going to be tied to your emergency override and global data. If you need to tie it to something else, this is where you would go down and you can go to the application, hit lookup, and you could choose any application you actually have on here. So I don't have a bunch of stuff set up on here because I just turned this back into an RX controller, but say you wanted to turn it to a standard circuit. If you hit enter and you hit lookup, it's going to give you all these options. So you just choose defrost, for example. So every time this went into defrost, it would throw this case into emergency override. So if it goes into emergency override, this is usually like when you have a power failure or something else, it closes, shuts refrigeration off, shuts defrost off, shuts fans off, and puts the case into alarm. So if we go to our next tab, so this is only going to be on your ESRs. So you're going to have a minimum ESR value. It's always going to be 0. A maximum, you could change it from 100. Say if you have a really oversized system or a medium temp system on a low temp system, you could put the maximum value to 50. So that way it never opens above 50 because it shouldn't. And then pull down percentage. Now, this is extremely crucial, especially on newer high efficiency cases. So pull down percentage, I may go 20%. Okay, and then pull down time, I may go for 25 minutes. So 0, semicolon, 20 minutes. So for 20 minutes, it will not open that valve more than 20%. This is useful for high efficiency coils, so you don't overshoot temperature and or frost the coils up. Because a lot of these coils, they can't handle, the temp drop right away. So if you go right down to, say, like a 15-degree saturated suction temperature and you have a case designed for plus 25, it's going to cause it to right away frost the coil up. And once you frost the coil up, you lose all your airflow. So that's why you want to use pull down percentages. Produce cases, anything that's on a low temp rack, it's medium temp, you want to use pull down percentages. Now, if you come down here, your COM fail during EPR, I usually leave it at 50%. So temperature sensor fail, it's going to be at 50%. And then COM fail, if you lose COM with the EPR, it's going to be at 50%. So generally, I won't play with that too much unless I have like a low temp case or medium temp case on low temp. I'll like choose the average. So say if it's like 20% open, I'll go with that. So if you hit your next tab, it's going to show all your defrost times at the end. So see, our defrost times are evenly spaced out, 0, 130, 3, 4, and 6. So that, again, is how to set up a standard circuit. So we'll go over how to set up a case control circuit next, and then we'll keep going, and then eventually it'll all tie together into different groups. Thanks, guys. I appreciate everybody watching, and have a nice day.